Hey everybody, I hope you're doing well. Just wanted to go over the problems from yesterday so you can have a better understanding of what you're doing. The first problem, number one, we have the integration of 7x to the fifth minus 5x to the fourth plus 6x squared minus 14x plus 3 dx. Now here we're just using that power rule of antiderivatives. So what we're doing is we're taking x to the fifth and we're adding 1 to it, and then we're dividing its coefficient by that new exponent. So we're looking at 7/6 x to the sixth. Then we have negative 5x to the fourth, so that becomes x to the fifth. Then we have negative 5 being divided by that new exponent of 5. I'm going to simplify that later. Then we have 6x to the third being divided by 3. And then negative 14x to the second. Right? We added 1 to that 1 to get 2. And then we're dividing by 2. And then when we have a constant, we are just adding an x after it. But then after we do this, we have to plus c at the end. That c represents that constant lost when taking the derivative, right? So the derivative of a constant is 0. So when we're doing the antiderivative or indefinite integration, which is what we're calling it now, we have to include that plus c at the end. Now I'm just going to go through and simplify all this. 7/6 stays as 7/6. Negative 5/5 becomes negative 1, or just negative x to the fifth. 6/3 becomes 2. Negative 14/2 becomes negative 7x squared plus 3x plus c. Okay. Moving on to number 3. Number 3, we have the integration of 4 minus 18w to the 11th minus 9w to the 9th plus 8w to the 7th plus 2w to the 5th dw. That dw is just telling you that this is the derivative with respect to w. So it's just telling you what the input value is. So to take the derivative of this, take it one term at a time, or sorry, to take the integration of this or the antiderivative of this, we are just making the 4 a 4w, or you can make it 4 over 1w to the first, minus 18w to the 12th divided by 12, minus 9w to the 10th divided by 10. So we're adding 1 to the exponent and then dividing by that new exponent. Then this is going to be 8w to the 8th divided by 8 plus 2w to the 6th divided by 6 plus c. Do not forget that plus c at the end. Okay, so now we're going to go through and simplify this. Yes, it needs to be simplified. 18/12, 6 goes into each, so we are looking at 3/2 w to the 12th. 9/10 stays as 9/10 w to the 10th. 8/8 would be 1. You could write 1 w to the 8th or just w to the 8th. 2/6 would be 1/3 w to the 6th plus c. Moving on to a much easier problem, number 5. We're looking at the integration of negative 7 dz. That dz tells you what that input value would be. So the answer to this is just going to be negative 7z plus c. Moving on to number 7. Looking at the integration of 10z to the negative 6th plus 8z to the negative 5th minus z to the negative 2 plus 1 dz. So same thing here, except we're dealing with negative exponents. Be careful when you're adding 1 to a negative exponent. All right, a lot of people like to subtract a 1 or make the -6 a -7. That would be subtracting 1. So we have 10z to the -5th divided by -5 plus 8z to the -4th divided by -4 minus 1z to the -1 over -1 plus 1z plus c. Now, if we simplify this, we get -2z to the -5th minus 2z to the -4th plus 1z to the -1 plus 1z plus c. I'm fine with you leaving it just like that. You don't need to move the negative exponents down. You could move them down to make it -2 over z to the 5th minus 2 over z to the 4th plus 1 over z plus c, if that's how the worksheet left it. But right here is fine with me. So you don't have to take it much further. Okay, let's move on to number 13. Number 13, we have the integration of the 7th root of w squared plus 3 minus 9 times the cube root of w to the 7th dw. First thing I have to do is I have to rewrite this. So this is the integration of w to the 2/7. Right? The exponent goes at the top. Whatever the root is of goes to the bottom. So plus 3 minus 9w to the 7/3 dw. Okay. The tricky part about dealing with these fractions is now you have to add 1 to the fraction. So this becomes w to the 2/7 plus 1, which would be 7/7. Okay, so 2/7 plus 7/7, that would be 9/7. So now I have to divide the 1 by 9/7, which would be 1 times 7/9. So when we're dividing by a fraction, it's multiplying by that reciprocal. So this becomes 7 over 9 w to the 9/7. Okay, and then plus 3w, that one's easy, minus 9w to the 7/3 plus 3/3. So we are looking at -9w to the 10/3. So I'm dividing -9 by 10/3, which is multiplying it by 3/10 plus c. So we have 7/9 w to the 9/7 plus 3w minus 27/10 w to the 10/3 plus c. Okay. That dividing by a fraction, so we're dividing 9 by 10/3, which is the same thing as multiplying 9 by 3/10, which is how we get the 27 over 10. Okay, I hope that makes sense. I know that's a little confusing. So we're adding 1 to the 7/7 and the 3/3, that's equivalent to 1. All right, moving down to what number's next? Number 17. Number 17, I have the integration of 8 plus u to the 5th minus 1 over u to the 5th plus 1 over 6u to the 5th du. Okay. Because I have our variables in the denominator, I have to move them up to the numerator. I have to rewrite this. So this is going to be the integration of 8 plus u to the fifth minus 1u to the negative fifth plus 1/6. That 6 still stays down, u to the negative fifth du. All right, so now when I take the integration of this, that u tells me what the variable is. So this is going to be 8u plus u to the sixth divided by 6. So that'd be 1/6 u to the sixth minus 1u to the negative fourth divided by negative 4 plus 1/6 u to the negative fourth divided by negative 4 plus c. Okay, so that 8u is good. The 1/6 u to the sixth is good. Negative 1 divided by negative 4, that's 1/4 u to the negative fourth. Now 1/6 divided by negative 4. There's two ways to look at this. You can look at it as 1/6 divided by negative 4 over 1, which would be 1/6 times negative 1/4, which would be negative 1/24. Or you can know that when you're dividing a fraction by a constant, just multiply the denominator by that constant. So this would be negative 1/24 u to the negative fourth plus c. Okay. So if you want to rewrite this, I'm fine with you leaving it like this, but if you want to rewrite it, or you did rewrite it, you can take those negative exponents and put them in the denominator. So this would be 1 over 4 u to the fourth minus 1 over 24 u to the fourth plus c. All right, let's move on to number 19. Number 19, we have the integration of the cube root of t to the fifth minus 1 over the square root of t to the ninth plus t to the fourth dt. So if we rewrite this, it's going to be a little complicated because I have that square root in the denominator. We have the integration of t to the 5/3 minus 1t to the negative 9/2. Okay, now you're probably wondering where I got that halves from, right? That is that 2. When you don't see a root in the square root in the radical, it's a 2. So that's why we have 9/2. Why is it negative? Because it's in the denominator. So then plus t to the fourth dt. Now we're ready to take the integration. So we have t to the 5/3 plus 1, and 5/3 plus 3/3 would be 8/3 divided by 8/3 minus 1 t to the negative 9/2 plus 2 over 2 would be negative 7 over 2 divided by negative 7 over 2 plus t to the fifth, and then we're dividing it by 5 plus c. So this would become, I have 1 divided by 8/3. When I'm dividing by 8/3, I'm multiplying 1 by its reciprocal. So this would be 3/8 t to the 8/3. Then plus, so I have negative 1 divided by negative 7/2. So negative divided by a negative would be that positive. And then I'm multiplying by the reciprocal. So that'd be 2/7 t to the negative 7/2 plus 1/5 t to the fifth plus c. Okay. Now we are dealing with some trig rules, okay? So 31. We have the integration of 6 sine of t minus 2 cosine of t dt. Right, I did post some rules of trigonometry, rules of the trig integration. Having those out, it's really going to help you with this. So here we are looking at 6 sine of t. Now that 6 kind of just stays out front. So this would be 6 times the integration of sine of t. Now, if you remember your integration rules, the derivative of cosine was negative sine. So the derivative of sine would be negative cosine of t, right? And then for this next part, we have negative 2 times the cosine of t dt. Now, if you remember, the derivative of sine was cosine. So the integration of cosine would be sine of t plus c. So we have 6 times negative cosine of t, because the integration of sine is negative cosine. So this would end up being negative 6 cosine of t, just to kind of clean it up a little bit. And then the integration of cosine is sine, because the derivative of sine was cosine. So minus 2 sine of t plus c. All right, on to number 33. Number 33, we have the integration of cosecant squared of y. There's no need to put the y in parentheses, minus secant squared of y dy. And these, you have to know the rules. So the derivative, so what gives you the derivative of cosecant squared? That would be what, cotangent. So the integration of cosecant squared is going to be negative cotangent of y. And then the integration of secant squared, if you remember, the derivative of tangent was secant squared. So the integration of secant squared is going to be tangent. So minus, we could put a 1 in here, so minus 1 tangent of y plus c. So we're looking at negative cotangent y minus tangent y plus c. Okay, I know that's a little strange, but you got to look at the rules you have here for cosecant and secant. Okay, and look at the constants that are in front of it. You have a subtraction sign, you have to make sure you have that negative 1 there. Now moving on to the last problem, number 37. Pretty straightforward, pretty easy. 37, we have the integration of w squared plus 2e to the w dw. Okay. Here, you just have to know when you're taking the integration of e to anything, or e to w is going to be ew plus c. So the antiderivative of w squared, I'm going to do this over here because I'm running out of room on my paper. This becomes w to the third divided by 3 plus 2 times e to the w. Now that 2 stays out front. It's a constant that just gets brought down with it. The integration of e to the w is e to the w. And then you can't forget your plus c. So we're looking at 1/3 w to the third plus 2e to the w plus c. All right, that about does it. I did post other assignments for you to do today from the same worksheet. I hope me going over this is going to help you with those problems today. We're going to work through this a little at a time. Please let me know if you have any questions. All right, have a good one.